Hello everyone, welcome to Hebbar's tutorial. I'm Kishore Hebbar. This video is about depth first search with the real-time example. DFS is a search algorithm used to explore nodes of a graph or tree vertically. The algorithm starts at the root node. There is no need to be start from any particular node, so I'm just taking an example from here. You can start even from here. It's a condition or nothing which avoids that, and then starts examining each node and until it reaches end of the node, end of the branch. Then it backtracks, then it goes back, then it finds another node which it needs to be searched for. So for this whenever you see or hear about the DFS, it's always a data structure. You need to use a stack or recursion. Let's go through the DFS using an example. Consider that we have a community of houses, and our goal here is to find the owner Jack. And the person who is searching is starting with the house which is 101. And each house can be represented as a node. We can have set of properties in a house or node. For simplicity, we just have a house number, owner name, neighbor details as a parameter. And for tracking purpose, we can also have is visited, which is a Boolean parameter inside the node. So that is to make sure that once you already visited for that particular node, you don't want to search again. For example, Sheldon neighbor is Rohan, as well as the Ria's neighbor also Rohan. If you're coming through the Sheldon and already visited Rohan, you don't want to again, while you're exploring the Ria's neighbor, you don't have to go through the Rohan again. That is to avoid the duplication while searching. At the beginning, we will add the owner Kevin to stack. So this is how, this is a stack mechanism where you first push the stack or the owner node to the stack. Then the loop continues. So here we are using the while loop just to make sure that that particular condition is that stack should not be empty. So whenever the stack is empty, then you will come out of that loop, or if you find the owner, then you will come out of that loop. So let's see what happens next. Inside the loop, we pop the item from the stack. And as you know, stack is last in, first out. That means whichever item entered last to stack will be out when we call the stack pop. So this is, you can see it's a stack. We pop our ID 101 or the node 101 from here. In this case, we get the last inserted item, owner Kevin. Then it will check if the node already visited or not. Since this never visited, it enters the loop and marks as visited and checks if the owner in this node is Jack or not. If no, then it will add its neighbors to stack. As you can see, neighbors to owner Kevin are Mohan, Ria and Sheldon. And also here you can see the visited so far boxes. So currently this particular research already visited Kevin. And the stack contains 101, 103 and 102. So next code will pop the next item from the stack. As you can see, last inserted was 104, which is Sheldon, and the code starts working on that now. It checks first whether this was already visited or not. Since it was never visited, then it enters the loop and marks the node as visited, and then checks whether the owner is Jack or not. Since it is not, it continues and then inserts its neighbor 101 to stack. So stack is, as I already mentioned, it will add on top of the existing one. So 101 is the latest, and also here you can track it. So we already visited 101, next 104, and also highlighted here with a yellow. These are all the visited nodes. Again, code will pop the next item from the stack. As you can see, last inserted was 107, and the code starts working on that now. It checks first whether this was already visited or not. Since it was never visited, then it enters the loop and marks the node as visited, and then checks whether the owner is Jack. Since it's not, it continues, but there is no neighbors to add for 107. So stack remains the same. So the latest now you can see it's 103. So there is nothing to add newly to that, new node to that. So code will pop the next item from the stack. Now we see the first available from the stack is 103, and the code starts working on that now. It checks first whether this was already visited. And since it was never visited, then it enters the loop and marks the node as visited, and then checks whether the owner is Jack or not. Since it is not, it continues, then inserts its neighbor 106 and 107 to stack. So here is an interesting part, because Ria has the same neighbor, similar neighbor as Sheldon, which is a common neighbor, which is Rohan. So you will come across that scenario in a few minutes. So once this is done, so code will pop the next item from the stack. Now we see that first available from the stack is 106, and the code starts working on that now. It checks first whether this was already visited or not. Since it was never visited, then it enters the loop and marks the node as visited, and then checks whether the owner is Jack or not. Since it is not, it continues, and this has no neighbors to add as well. So currently you can see here till 101 to 106 are visited nodes. After this, code will pop the next item from the stack. Now we see first available from the stack is 107, and the code starts working on that now. It checks first whether this was already visited or not. As you can see here, this node was already visited before. So we don't go to that house or the node to search for Jack, because this was explored while by going through this route, Sheldon, then Rohan. So we skip this one. After this, code will pop the next item from the stack. Now we see first available from the stack is 102, and the code starts working on that now. It checks first whether this was already visited or not. Since it was never visited, then it enters the loop and marks the node as visited, and then checks whether the owner is Jack or not. Since it is not, it continues and adds its neighbor 105 to stack. After this, code will pop the next item from the stack, and now we see first available from the stack is 105, and code starts working on that now. It checks first whether this was already visited or not. Then sets this node as visited, and it checks if the current house owner is Jack or not. And here we found Jack. With this, search completes. And here you can see how the node class is defined. This is using Java, and it has the properties of house number, owner, is visited, and the neighbors. And also previously I missed to mention that what are all you can also see what are all the visited nodes here from the 101 till 105. So this is how it went: 101, 104, 107, then backtracked, then 103, 106, then again it backtracked to 102 and 105. And also you remember that it never visited the node which already visited. So it avoids the duplication. And here this is the logic using the stack. It is now easier for you to go through the method. As you can see, first we add the root node to the stack, Then we check if that was visited or not. Then we check if the owner is in the current node. If not, we add the neighbors to stack and the loop continues until we find the owner. Here is the code to initialize the tree. So here you can see initialize the node 101 with Kevin and ID is 101, so on until 107. And also you can see 101 neighbors, setting the neighbors as 102, 3, 4. For the 102 neighbors as 105, and for 3 it is 6 and 7, and 4 is 7. And I'm trying to find the person or the owner Jack and starting with the node 101. As I mentioned before, you don't have to go start with the 101. You can choose any node. You can then start with 104 to start with the DFS. Thanks for watching. Please like and subscribe. If you have any questions, please comment below. Thank you.